Happy Monday. Today we're going to continue learning about inequalities. This is chapter 8, lesson 5. You need to be on page 635. Remember, this is a notes video, so you have to take notes and you need to write in your textbook. So if you don't have access to your textbook, make sure you find it and write in it. And I highly recommend you do not rip these pages out to take the picture. The whole point is to keep them in your textbook so you have them to go back to make reference to when you have a quiz or a test or need to go back and look up information. So don't rip the pages out, and please write in your book. All right, that being said, this first part, I just needed to write down what's on the screen. So an inequality is a mathematical sentence that compares quantities. The definition of an inequality is a mathematical sentence indicating that two quantities are not equal. And the symbols you're going to use to express this comparison are, the first symbol is, this is right here, is greater than. Then we have less than. We should be very familiar with those. The next two may be new to you, or you may be a little bit familiar with them. This is greater than and equal to. It combines the equal sign with the greater than sign. And this last one is less than and equal to, or equal to, excuse me. Now an example would be 6 plus x is greater than 13. This is an inequality. You can write another example if you want. An example of what is not an inequality is 6x is equal to 18. There is only one answer. If we divided both sides by 6, x is going to be equal to 3. And both sides are equal expressions. This is not an inequality. So what I need you to do is press pause. You can make sure you're on full screen so you can see everything you need to write down. If you can't get to full screen, you can use control plus sign usually to zoom in, but in some fashion I need you to make sure you have all this written down for the notes pictures you need to take after we are done. Go ahead and take some time to do that now. Press pause and write. All right, so we're going to take some time and practice using the greater than and less than symbols to compare two quantities. So for the first one, it says the score after 2 goals is what compared to the score after 3 goals. Okay, so 2 goals is going to be less than 3 goals. Number 2, the cost to download 10 songs is what compared to the cost to download 2 songs? Okay, most of the time, each song is going to be the same amount. So if you're downloading more songs and you're paying for each song, then 10 songs are going to be greater than 2 songs. There might be some exceptions, but for the most part. Number 3, the outside temperature in the summer is what compared to the outside temperature in the winter? So what's it going to be? Greater than or less than? Okay, so the temperature in the summer is definitely going to be higher generally than the temperature outside in the wintertime. So that's going to be greater than. And so number 4, the height of a first grade student compared to the height of a sixth grade student. Now we know there can be some exceptions, but generally speaking, is a first grade student going to have a height that's less than a sixth grade student or greater than? Go ahead and answer that for me. Generally speaking, first grade students are less than the height of sixth grade students. The time, to eat lunch is greater than the time you spend brushing your teeth, less than the time you spend brushing your teeth. And again, we're thinking generally. Do you usually spend more time eating lunch or more time brushing your teeth? Go ahead and answer that for me. Most people will spend more time eating lunch than they do brushing their teeth. So usually brushing your teeth about 2 minutes, and most people spend more than 2 minutes eating lunch. So the time you take to eat lunch is generally greater than brushing your teeth. Okay. Okay, just like equations, you can use symbols and words and pictures and models to actually represent them. The symbols for inequality are less than. The words would be is less than or is fewer than. And here's an example of an expression, an inequality expression: 3 is less than 5. Then there's the symbol greater than, and the phrases that go with that: is greater than, is more than. And an example of an expression would be 8 is greater than 4. We also have is less than or equal to, and the phrase is less than or equal to, is at most. That's expressing that this is the maximum, that's the minimum. Okay, so if something is either less than or equal to, then there's a maximum amount, and then everything else has to be less than that. And then we have this symbol, which is greater than or equal to, and the phrase is greater than or equal to. Is at least is another possible phrase associated with that. 12 is greater than or equal to 9. So in this case, there's a minimum, and that anything else must be greater than that one thing that could be equal to. Okay, so just like equations, we can do kind of a guess and check situation in which we take values and we replace the values with whatever the variable is and see if the inequality is true or not. Now, unlike an equation, equations only have one possible answer, but inequalities actually could have more than one value, and usually an infinite number of answers that could actually make the inequality true. So let's go ahead and look at the example they've given. In this situation, they want you to check to see if 6, 7, or 8 will make the inequality f plus 2 is less than 9 true. All right, so if we write this out and we replace the f with 6, 6 plus 2 equals 8. 8 is less than 9, that is true, so that makes a true statement. And then if we replace f with the letter 7, the number 7, 7 plus 2 is 9, and 9 is not less than 9. 9 is equal to 9, so this is actually not a true statement. Had this been less than or equal to, that would be a true statement, but that is not what it says. It says less than. Now, finally, we're going to put the number 8 in the situation. 8 plus 2 equals 10. 10 is not less than 9. So of these three numbers, the only one that will make the inequality true is the number 6. However, 5 would have also worked. 4 would have also worked. 3.5 would have worked. 2.1 would have worked. There's actually an infinite number of situations that would have worked, but of those three numbers, only 6 works. We're going to practice evaluating the inequality n minus 3 is greater than 6, and we're going to do that by replacing the n with 3 possible answers: 8, 9, and 10. So we're going to write the inequalities out 3 times. So we're going to write 8 minus 3 is greater than 6. Then we're going to write 9 minus 3 is greater than 6. And then we're going to write 10 minus 3 is greater than 6. Okay? Now we're going to evaluate the first part of the expression. That means basically solve the first part. So answer this for me. What is 8 minus 3? If you said 5, that's correct. So now I'm going to rewrite the expression. What is 9 minus 3? Answer that, please. Very good, 6. So we're going to write that expression. And then what is 10 minus 3? You're correct, that is 7. So we're going to write that expression. And for the final part that we need to do to solve this, and make sure you're writing all this down so you can turn in your notes later. Which one of these is actually correct? Which one makes a true statement? Is 5 greater than 6? Is 6 greater than 6? Or is 7 greater than 6? Pick one that's actually a true statement. Okay, if you said 7, you're correct. 7 is greater than 6. This is the only one that actually would be correct. So that means that 10 is the value that makes the equation make sense. But you know what? 11, 12, 13, 14, 100,000, 200,000, 500,000, all of these numbers, an infinite number of numbers, would actually make the statement true. But in this case, this is the one of those three that makes it true. Okay, now we're going to determine the solutions of an inequality. And basically, it says since an inequality uses greater than and less than symbols, one variable inequalities have infinitely many solutions, which we've already discussed that. For example, any rational number greater than 4 will make the inequality x is greater than 4 true. If you have if a given value makes an inequality true, then you've determined a solution to that inequality. Okay, now remember, rational numbers can also include decimals and fractions and all sorts of things like that. Okay, now we're going to look at some examples of how we plug in the one answer to see if it makes it true or not. Is the given value a solution to the inequality? So x plus 3 is greater than 9. So if they want you to check to see if 4 will work, you just replace the letter x with the number 4. 4 plus 3 is 7. 7 is not greater than 9, so you just cross it out with a little mark there. So that's not one of the solutions. Now, 12 is less than or equal to 18 minus y. And if y is 3, let's try this out. Okay, 12 is less than or equal to 18 minus 6. 18 minus 6 is 12, and 12 is equal to 12, so that is a possible solution. So that's going to be correct. And then the final example for this section, it says 17 is greater than or equal to 11 plus x. And if x was 8, 11 plus 8, 11 plus 8 is 19. So write the inequality, replace x with 8. And since 17 is not greater or equal to 19, then 8 is not a possible solution. All right, we're going to practice a little bit. B says a plus 7 is greater than 15. So if a was 9, we're going to put 9 in the place of a. 9 plus 7. So what is 9 plus 7? Go ahead and answer that for me. Okay, that was a 16. Is 16 greater than 15? Yes or no? Then that is a possible solution. All right, C asks us if 22 is less than or equal to 15 plus B, and B was 6. Would that make the equation true? Is that a possible solution? Okay, what is 15 plus 6? Go ahead and answer that for me, please. 15 plus 6 is 21. So if I write the rest of the expression out and then read it, is it a possible solution? Oops, hello. 22, is it less than or equal to 21? No. That is not a possible solution. Okay, so I think we get the gist of it without doing those final two. For the most part, you're just going to replace the variables they ask you to with the quantities they ask you to see whether or not the inequality makes sense. And there are an infinite number of solutions to all inequalities, but not every single number will work for every inequality. So could you please tell me what you think the most important thing it is that you have learned in this lesson about inequalities? Go ahead and answer that for me now. Okay, thank you for giving me a thoughtful answer, and I'm glad that we can look back into the book and at a couple pages we've done notes on. If we